So we're now going to talk about the average rate of change. Average rate of change is very similar to our slope formula, which was y2 minus y1 over x2 minus x1. And that would give us our slope m here. So that was for a linear function. So any function that was a straight line in the coordinate plane, something like that. We could pick any 2 points on this line and find the slopes. But suppose we have a function that isn't linear, something like this, some random curved lines, and we wanted to find the rate of change between, let's say, these 2 points here. Something like that. That would allow us to use the average rate of change formula, meaning how fast or at what rate is the function changing along this curved line. So it's not as confusing as it seems when you compare it to y2 minus y1 over x2 minus x1. So let's take a look at the first example here. So for the first one, it says find the average rate of change over the domain interval 0 to 4. So 0 is our a value and 4 is our b value. So now let's find f of 0 and f of 4. So f of 0 would be 3 times 0 minus 1 plus 4 times 0. Then we would have f of 4, which is 3 times 4 minus 1 plus 4 times 4. Now if we get those values here, we would get 3 times negative 1, which is negative 3, so this here, plus 4 times 0 would be negative 3. This one we have 3 times 4 minus 1, which is 3 times 3. That's 9, plus 4 times 4, which is 16, gives us 25. So that means we have our values f of 0 equals negative 3, and f of 4 equals 25. So now let's take a look at this formula here and use those values. So f of b minus f of a. This here would be our f of b. This would be our f of a. So f of b was 25. F of a was negative 3. So 25 minus negative 3, and then over b minus a. So our b value was 4, our a value was 0. We do 4 minus 0 here. We get 28 over 4, and now our average rate of change is 7. Let's go ahead and do the same thing for letter B. So I'll change colors here so we can see the difference. Here is our a value. Here is our b value. So now what we're going to do is we're going to do the same steps and find out what f of a is. So f of negative 2, and then also our b value, f of 2. So let's go ahead and plug those in. So we have 3 times negative 2 minus 1, 3 times 2 minus 1. This is plus 4 times, let's erase a little bit of this here. Times 4 times negative 2 plus 4 times 2. So let's go ahead and find that out. So we have 3 times negative 2 minus 1, which is negative 3. That gives us negative 9. Plus 4 times negative 2, which is negative 8. So when we do that, we get negative 17 as our value for f of a. And again, negative 2 is our a value. Positive 2 is our b value, okay? So we're finding it between the two endpoints of this domain. F of 2 would be 3 times 1, which is 3, plus 4 times 2, which is 8. So we get 3 times 1, which is 3, plus 4 times 2, which is 8. 3 plus 8 gives us 11. Let's go ahead here and solve. So f of b, which was f of 2, is 11. So we have 11 minus negative 17 over b minus a, 2 minus negative 2. So 11 minus negative 17 would be 28. 2 minus negative 2 would be 4. We divide those, our rate of change, again, here is 7. So let's now go ahead and do the same thing here with exercise number 2. We are using the function g of x here, and our a value is negative 3, our b value is 5. So let's go ahead and plug these in to the function. So g of a, we have negative 3 plus 3, which is 0, and then 4 times 0 is 0. So that gives us 2 minus 0, which is just 2. Now we have negative 4 times 8 as such. So 2 minus 32, that would give us negative 30. So here's our g of a and g of b. So let's go ahead and plug that into the formula. And remember, it was f of b minus f of a. Again, it doesn't matter what letter we use. G is still the same thing, all over b minus a. So g of b was negative 30 minus g of a, which was 2, all over b minus a. So 5 minus negative 3. So here, when we do this, we get negative 32, negative 32 over 5 minus negative 3, which is positive 8, which gives us the rate of change of negative 4. Let's go ahead and do the same thing for this interval. We're working with decimals here, but nothing changes. So here's our b and our a. Let's go ahead and plug in and see. So we have g of 2.75 plugged in here would be 2 minus 4 times 2.75 plus 3. And then our g of b would be mixed them up. This is our b here. This is our a, 2.5. So this is 2 minus 4 times 2.5 plus 3. That will get us our answer. So don't get it confused. This is our a, this is our b, and we go ahead and we test this out. So let's put this inside the parentheses. Made a slight error here. Plus 3. So when we go ahead and solve, and I'll change colors here so we can see, we have 2.75 plus 3, which is 5.75. Then we have to multiply that times 4 times 5.75. We get 23. So we have 2 minus 23, which gives us negative 21. For this one, we have 2.5 plus 3, which gives us 5.5 times our 4 gives us 22. So we have 2 minus 22, which gives us, make sure it's correct, 2 minus 22 gives us negative 20. So there's our f of b and our f of a. So let's go ahead and do it. F of b is negative 21 minus negative 20 over b minus a, which is 2.75 minus 2.5. So let's go ahead and do that. Negative 21 minus negative 20 gives us negative 1. 2.75 minus 2.5 gives us 0.25. Then if we divide those, we get negative 4. So what do we notice? Let's look at exercise 3. What is one observation you can make about the rate of change in the two functions in exercise 1 and exercise 2? We notice these slopes are the same. So what does that mean over those intervals? If the slope is the same the whole time, there's no way it's a function that has curves in it like this. It has to be a linear function. So that's a huge piece of information for us. So due to the fact that the slopes are the same between different intervals, that lets us know that these are linear functions. So for exercise 4, we're given f of 2 equals 8. So f of 2 would be our a value, and f of a equals 8. Same goes for b. 6 is our b value. F of 6 is 28. Now, what is the average rate of change between these 2 points? So our f of b is 28. F of a is 8. B minus a would be 6 and 2. So here we have 20 over 4. That means our rate of change would be 5. So let's go ahead and take a look at exercises 5, 6, and 7 here. So exercise 5 says the Bernstein family is taking a trip to Pennsylvania. After 2 hours, they have traveled 120 miles. And at the end of 5 hours, they traveled 210. So 2 hours would be our A, and 120 would be our F of A. 5 hours would be our B. 210 miles would be our F of B. So let's see what part A says. It says, what was the average rate of change the Bernstein family was traveling between hours 2 and hours 5? So again, hour 2 was our A value. 120 miles was our F of A. 5 hours was the B, and 210 miles was the F of B. So if we do our F of B minus A, we have 210 minus 120 over 5 minus 2. And that gets us, just to make sure here, that gets us 90 over 3, which would give us 30 miles per hour. So it's important that we put our label for units here. We traveled 30 miles per hour. So our top value was miles, our bottom value was time, which was hours. Let's go ahead and look at part B. It says, what was the average rate of change the Bernstein family was traveling for the first 5 hours? So we have to account for when they first started. So after 0 hours, they've driven 0 miles. That's their starting point. So that would be our A and our F of A. Then we have our B value at 5 hours and F of B being 210. So we then have 210 F of B minus F of A, which is 0, over 5 minus 0, which gives us 210 over 5. So that means over their whole trip, they were traveling 42 miles per hour on average. Number 6, a 1-year-old baby weighs 24 pounds. So there is our A value with our F of A value. So at year 1 is our A. That's our F of A. And then the baby is 4 years old. She weighs 39 pounds. So our B value and then F of B. It wants to know the average rate of change of the weight of the baby over this time period. So F of B is 39. F of A is 24. B minus A, we are able to get 15 over 3, which means the baby gained weight at a rate of 5 pounds per year on average. And then our last one, we say a winter snowstorm begins on Monday at 3 o'clock. So that's when it begins. So that's our 0. So 0 hours. Again, we have to make sure we label starting point. Obviously, there's no snow on the ground yet. So there's our A and our F of A. And then by 10 o'clock, so after 7 hours, B, and then our F of B, because that's how much snow fell, we then need to find the rate of change. So what we would do here is the same thing we've been doing, 17.5 minus 0, our F of B minus F of A, and then B minus A, which is 7 minus 0. So we have 17.5 over 7. That would give us 2.5 inches of snow per hour. That is our average rate of snowfall.